Okay, here we go. We got homework 2-4. This may take a few minutes because we got a lot of ground to cover. But this first one is just a matter of reading and then paying attention to the different symbols. So you're going to read through and you're going to look for the population mean versus the sample mean. So there'll be a population and then they'll take a sample from that population. Okay, there'll be a population standard deviation. So a standard deviation of everybody in the group, that's the population. But they'll take a sample of that and come up with a sample standard deviation. And then you've got to make sure you know what the symbols for these things are. So here's the symbol for the population mean. Here's the symbol for the sample mean. Population standard deviation has this symbol, and then just an S, lowercase s, for the sample standard deviation. So, you just got to make sure you're picking the right symbols there. And make sure you know these symbols. You are going to see these at some point on a pop quiz. I am going to say, give me the symbol for the population mean, or symbol for the sample mean, and you got to be able to write those things down. Population standard deviation, sample standard deviation. Give me the symbols. You got to be able to write those things down. So make yourself a note. You're gonna see that at some point, pretty soon. Okay, so we did, in the last homework, we did standard deviation of a set of numbers. Now we are given a histogram, and we've got to try to estimate the standard deviation of these 32 numbers. But we can't see all 32 of these numbers, but they're in these little bars right here. So the best we can do is estimate. All right, and so our formula, if you look at it, it's going to look something like this. This is a frequency. It's probably scaring some of you right now. All right, so that's going to be our formula. All right, this is the letter M, and I'll tell you what that means in a minute. Now, you just saw me write this symbol right here. Quick refresher. Do you remember what does that mean? What does that little symbol mean? If you were paying attention, you would know it means the sample mean. So the first thing you're going to have to do is find the mean of this histogram here. All right, and you did that. You did that in a previous homework. So if you remember how to do that, what you had to do is you'd find the midpoint of each of these bars. So like here, this is -6. This is -2. This is 2. And this is 6. You take those as the estimates for the numbers in that bar. So there's 6 numbers here. So I'm going to say this is 6 times -6. This is 14 times -2. This is, what am I doing? 10 times 2. And this one is 2 times 6. So I'm gonna multiply all these together. That, then add them together. And then divide by the total number in there, which is 32. So I'm gonna take that number, whatever that number is, and divide by 32, and that'll give me my X bar. All right, I'm gonna do that real quick. All right, so do the calculations. That comes out to be -1. All right, so this -1 goes into this part of the formula right here. All right, so this M here, stands for the midpoint of each bar. So if you remember, get rid of some of this. Sorry, my wife's in there cooking. So the midpoint of this bar here is -6. So it's gonna be I take the midpoint, -6. I subtract the mean, which we just found out was -1. I square that, and then I multiply that times the frequency of that bar, which in our case, this was 6. So there'll be a 6 out there. All right, and then this summation symbol means I'm gonna be adding some things. So the next thing, I'm gonna take this next bar, I'm gonna say the midpoint of it is -2, and the subtract the mean, which was -1. I square it, and then multiply it times the frequency of that bar, which is 14. Do the next bar. Frequency of that bar is 10. The midpoint is 2. Subtract the mean, square it, and lastly, I'm going to take the frequency of that last one. The midpoint is 6. Subtract the mean and square it. So I've got to add all of that up. All right, so it's real careful. Don't make a mistake here. One little slip of the finger could cause you to miss it. So you add all that up. Then you're going to, so that's the top part of this is what you've just done. Then you're going to divide by. All right, so you shouldn't be knowing what this lowercase n means too. That's another thing that I'm going to ask you to know what that means. That is your sample size. Your sample size is 32. Okay, so we're going to do 32 minus 1. I'm going to divide by that. And then I cannot forget the last step. I got to take the square root of that whole thing. Wow, a lot of stuff there. But that is how you're going to estimate the standard deviation of a histogram. Okay, so just to review, first thing you're going to have to do is find the mean, the sample mean. So you got to do that first. All right, and then you use the formula. Then use your formula. All right, it's going to take some practice, but you can do it. Oh, shoot. Sorry about that. All right, here we go. Now, here we go, people. This is it. This is one of the most important things I'm going to teach you all year. You are going to run across this this concept the remainder of the year. Very, very important. So some things. So this is called the empirical rule. All right. So this empirical rule only works. You can only use the empirical rule when you have a normal distribution, and we sometimes call that a bell-shaped distribution, or we also call it, what else do we call it? It's more of a symmetric, well, normal and bell-shaped are the main thing, but it's also symmetrical. Meaning that if you fold it in the middle, it should almost match up. It may not match up exactly, but it'd be close to matching up. Okay, so that's the only time the empirical rule works is when you have a distribution like that. So I can't use the empirical rule with this data right here. It is not a normal distribution, okay? If you want to test yourself and you're asking, is that skewed left or skewed right? All right, I'll let you get an answer. Log it in. The answer is this data is skewed to the right. It's skewed right because most of the data is over here in the left. This is where most people are, but then you got these few people over here that are skewing things up. Okay, so it's skewed to the right. All right, so empirical rule says this. If you have a normal distribution, so you have a bell curve, the mean of that the mean is going to be right in the middle. I'm going to use my symbol for mean here. And then if you move out one standard deviation on both sides of the mean, 68% of your data is going to fall within that range. All right, so let's look at our example up here. It says, what do we got here? We got 95 viewers spent watching it. The histograms show the distribution of 2 data sets. Each histogram shows the time in minutes. Okay, so this data right here, the symmetrical one, somewhat symmetrical, the mean is about 44.37. Okay, so that's that number right in the middle. It's around 44.37 is some, if we did the mean, it'd be right about there. Standard deviation, it says, yeah, standard deviation is 8.12. All right, so if I added 8.12 to that number right there, and I subtract 8.12 to that number right there, let me see what I get. Okay, so I do the addition, I do the subtraction, and I get 52.49 for the upper bound, 36.25. So that's just, those numbers are one standard deviation away from the mean, okay? So what that tells me is there's approximately 68% of the data is gonna fall between those two numbers right there. All right, so important thing to remember, one standard deviation in the empirical rule on either side of the mean means 68% of the data is going to fall in there. All right. If I were to go out 2 standard deviations, the empirical rule says that approximately 95% of the data is going to fall between those two numbers, whatever those are. So I would, if I wanted to find those numbers, I would take this, I could just add another standard deviation to it, or double this number here. But I would just add another 8.12 to that, or subtract another 8.12 from that, and whatever those two numbers are, I'm going to be within 95% of the data is going to fall between those two numbers. And then if I go out one more standard deviation, 99.7, that's just about everybody, okay, is going to fall within 3 standard deviations. Not everybody, but just about everybody is going to fall within 3 standard deviations of the mean. This information right here, imperative, all right? You're going to need to know those numbers. Yeah, you're going to have to carry that around with you for the next 3 months, all right? This only works, only works if this is a normal distribution, okay? Or bell-shaped distribution. All right, so when you're solving this problem right here, it said, first thing it says, identify the data set for which is appropriate for the empirical rule. So you're going to pick the normal distribution. All right, the second one, the percentage of times between 20.01 and 68.73. What you would need to do, if you need to figure out how many standard deviations these numbers are away from the mean. Okay, so one way to do that is just start with your middle number here. Start with our number, our 44.37, and just keep adding a standard deviation to it until you hit that number. I'm pretty sure you're going to have to add 3 standard deviations or subtract 3 standard deviations to get these numbers right here, which would mean 3 standard deviations, approximately 99.7 is what answer I would pick there. All right, and then if I'm looking for 95% of the times are between what two numbers, I'm gonna take my mean, add the standard deviation twice, subtract the standard deviation twice to get these two numbers that would go right here. All right, this is gonna be, you need to really make sure that you understand how to do these. This is one you're gonna see a lot of. So I chose to do it one more time because I had a lot of stuff written down before. So let's see what you remember. Which of these two curves can I do the normal, do the empirical rule with? I can do it with this one right here because it is somewhat symmetrical. It is somewhat bell-shaped. Got that little, well, come on, Paul. I got that little bell going right there. All right, this one here is skewed which direction? Skewed right. These little guys over here are skewing things up. Most of the data is on the right side over here. I mean left side, sorry. So these are the ones on the right are skewing it. Okay, so this is a normal distribution here for part A. So we're gonna pick A for that one. The mean of that, let's see here, the mean is 59.93 it looks like. .93, and the standard deviation for that is 15.01. All right, so question first says, the first question we did A. The next one is saying the percentage of incomes between 29.91 and 89.95. So I'm thinking, all right, I'm not gonna try to do this without a calculator, people. There's 59, this is my middle number, 59.93. And I wanna get to 89.95. I wanna get to this number right here on the big end. How many of these do I need to add to go from 59.93 to 89? Okay, so I'm looking, that's about a difference of 30, right? From 59 to 89 is about a difference of 30. That's going to be 2 of those standard deviations, okay? 2 standard deviations. The empirical rule says, what's the percentage? That's right, 95%, okay? So I would pick 95% here. And then if I want to know approximately 68% of the incomes are between what? 68% from the empirical rule, that is 1 standard deviation. And so I would start with my middle number here. Let me get that. Start with that 59.93. And then I would add a standard deviation. I'd say plus 15.01 and get my number for the lower bound. And then I would subtract 15.01 from 59.93 and get my answer. This was my upper bound. This is going to be my lower bound down here. I'll let you do the math on those, but it's just a matter of adding that and subtracting that from your mean to get your numbers there. All right, do I have any? Yeah, you might want to hit pause and come back to this one. Take a little break because that was a lot of stuff to remember right there. But this is going to be, we got 2 more, this one problem left. Again, important one. I like it because it really does make you think. So when I like a problem, that probably means you're going to see a lot of them. So, expect to see something like this. You've seen something like this when you were putting means in order. Now we're trying to put standard deviations in order, okay? So when you think of standard deviation, that's asking you how spread out is the data. So the bigger the standard deviation, the more spread out, okay? The bigger the standard deviation, the more spread out. Okay, so if you're looking at these and you're saying, well, which one is more spread out? I'm guessing just by looking at these guys, it's either this one or this one, right? It's definitely not B. B, it looks like it's more packed. It's closer to 9. Now, just to be aware, all of these are centered at 9. Every one of these data sets has a mean of 9. All of them have a mean of 9, but they all have different standard deviations. This one here, these blocks right here are all relatively close to the center, okay? which means its standard deviation is going to be smallest. Okay? That standard deviation is the smallest. The question is now, between these two, which one's bigger? Which one's more spread out? Excuse me. Well, these are exactly the same, right? These are exactly the same. Exactly the same. The only difference is this block here is one, and this block here, they're a little bit further out than this block here, okay? Which means this standard deviation is going to be the most spread out, or the data is the most spread out, so the standard deviation is going to be the biggest. So I'm going to say C is the biggest. C is the biggest, A comes next, and B would be the smallest, okay? So C is greater than A, and A is greater than B. Pretty sure I did another one of those so we could practice together. Yep. So we're looking, now notice, they're all centered at the same number. In this case, it's 8. The question is, which one is the most spread out? Which one is the least spread out? Okay, so I'm guessing they're usually just one block off. So like these guys right here, somewhat close, but they have these 2 blocks here, there. Those blocks are here, but like this, one of these blocks gets knocked over up here, okay? So I would say B is a little bit more spread out than A, or C, excuse me. So B is going to have a bigger standard deviation than C, simply because this block that's really close to the mean gets moved over here in this data. So B's a little bit, did I say that right? Yeah, B's a little bit more spread out. And then between A looks like it's going to be more spread out too, right? Because what happens is these 2 blocks on 11, one of those gets knocked over here. These 2 blocks on 5, one of them gets knocked over here. So it's even more spread out. So A is going to be even bigger than B, and we said B was bigger than C. All right, I like that problem. Y'all are going to see a bunch of them. Okay, you got plenty to do. Let me know if you need some help. Come see me at school or shoot me an email if you're staying home.